a little bit more about Lightcloud Blue sensors and how they work with RAB high bay fixtures. Let's get right to it and look at what different products we have in the high bay category that work with sensors. So we see here that we have a variety of different high bays. The ones that work with our screw-in sensors happen to be these guys right here from a linear standpoint, and these guys down here, which are round. All the 6 ones on the left, all the 6 products on the left, have a sensor port built into the unit. You unscrew a knockout, and you're able to screw that Lightcloud Blue sensor in. The one on the right, the Arrow Bay, that one you actually have to order from the facility because it doesn't have a knockout on the front of the unit. And at the facility, we put a little adapter piece on so that you can screw that sensor directly in. We do have a product selector guide. So specifically, when we're talking about Lightcloud Blue sensors, they sit in this location for those, the H15, the H17, the H22. Then the R bays over on the right with those linear solutions that we have. So let's get into these sensors and understand exactly what we have to offer. There happens to be 8 versions. So we have white versions, we have black versions, so that's 2. We have passive infrared, we have microwave, now that becomes 4. With these, there's the version that is mounted for a 20-foot mounting height, and then another version for a 40/50-foot mounting height. So now we have 8 different sensors, and every single one of these sensors have 3 separate functions. One is that it's a controller. Second is it's an occupancy sensor. And third, it's a daylight harvesting sensor. So when we look at these sensors and look at their capabilities, they're indoor and outdoor rated to IP66, which is actually higher than some of our fixtures. They're compatible with any 0 to 10 volt dim to off fixture that has a 12 volt output driver. With this, those 3 different functionalities that we saw before, you could have it be just a controller and turn off both of the sensors. Or you could have the controller with just the occupancy sensor. You could have the controller with the daylight harvesting sensor, or you can have it be a controller, occupancy sensor, and daylight harvesting all at once. So we're going to talk about 3 separate concerns with these sensors and how they're used on high bays. The first is you need to have constant power to that Lightcloud Blue device. This goes not just to these sensors, but any Lightcloud Blue device. Because what happens in this image that you see right here, when that occupancy sensor or that toggle switch has turned off, which means power is no longer going to the Lightcloud Blue device or the fixture, that means the radio is turned off. And if you want to be able to configure turn on and off the device, you can't because the radio is completely turned off. And that actually creates a hole in the mesh because now you don't have that device to be able to communicate with other devices inside the space. So what you want to do is you want to have line voltage going directly to the Lightcloud Blue device, that sensor, which in our case is line voltage directly to the fixture. So avoid putting any device downstream of any electrical component that interrupts power, like a photocell, photosensor, occupancy sensor, toggle switch, or other non-Lightcloud Blue switching device. So what you could potentially do if you have a toggle switch in that specific location, you could take one of these 3 models, and all 3 of these models aren't connected to a load. So what you would do is you would take the hot and neutral and ground that is coming into the box, you would wire that through directly to the fixture, and then you would take the hot and neutral and connect it to either the dimmer on the left or the dimmer in the middle. The one on the right doesn't actually have any wires, and we're going to get to that one shortly. So what that means is for that toggle switch that you have there in the corner as you enter the space, if you run line voltage directly to the fixtures and you run line voltage directly to this dimmer, the dimmer will speak wirelessly with all the other devices, and all the other devices will speak to each other also. If you want to, you could take another Z-dim and put it at a different location. Over here, you might steal that hot and neutral and ground from, let's say, an outlet or maybe a fixture up in the ceiling where you can take 277 or 120 down to this device, or you could potentially put another device over here as long as you can get line voltage to this Z-dim. So with these two different Z-DIMMs that we have right here, the normal dimmer on the left and the occupancy on the right, no load is needed or connected. You only have hot, neutral, and ground wires. You can control up to 199 devices in one area or 699 devices for the entire site. Some people want that dimmer to behave like a dimmer, dims up and down, or you can actually put it to switch mode where it just turns on and off and it behaves just like a toggle switch. The occupancy sensor one that we see there is either occupancy, which is automatic on, automatic off, or vacancy, which is manual on, automatic off. And you could enable the daylight harvesting in this device if you wanted to, down by the wall. The other device that we have is this self-powered dimmer. This self-powered dimmer has no wires, so no hot, no neutral, no ground, and it's not connected to a load, and it actually doesn't even have a battery inside. The one caveat with this, due to the fact that it has extreme functionality, mounting capabilities within a space, it requires installation of within 30 feet of a proxy device, and all of those high bays that you saw previously are a proxy device. The proxy device and this dimmer needs to be in the same area for it to work. Now, you don't have as much functionality with this. You either have on, off, you have dim up, and you have dim down. And it can control only 199 other devices in the area that it's installed in. The second issue that I want to mention to you happens to do with the communication range. Now, the Lightcloud Blue devices do a pretty darn good job. Direct line of sight, about 200 feet. If you have normal building materials, the communication range between all of the Lightcloud Blue devices is about 60 feet. So all the devices need to be within Bluetooth range of each other, or Bluetooth mesh wireless range within the, for each other. But when we talk about the mobile app, which is your mobile device, your phone, or the tablet, that is not part of the network. And it needs to be within 30 feet of another Lightcloud Blue device for it to communicate. But the thing about the mobile device, your mobile device range will depend upon the Bluetooth radio that's in your mobile device. Apple products typically have a range of 30 feet or less. Android devices have a range of 30 feet or more. And if we're talking about a high bay that's mounted 30 feet, 35 feet, 40 feet, you may have to go to an Android device to be able to get close enough so that you can actually set up and configure the system. The third thing that we want to talk about is occupancy sensor technology. Now, I mentioned before that we have we have passive infrared and we have microwave versions. The passive infrared has a slotted detection, and it needs to be able to have full view, direct line of sight of the human being within the space. It's great for rectangular spaces. It's really good for skinny, tall spaces like a hallway or a warehouse aisle. For the most part, you're going to be using passive infrared for most applications. There are a couple caveats. There's a couple things that have the passive infrared has a little bit of an issue with. Oh, forgot. With passive infrared, the occupancy sensor coverage patterns, you actually want them to overlap. And it's okay to overlap them significantly by up to 25%. There is a concern with the passive infrared. If you use a drop lens or if you use a refractor, that's going to either block the view with that refractor, or if you put a drop lens, you're actually going, that's like putting a blindfold on the fixture, and it's never going to see a human being, and it's never going to turn the lights on. So if you have a refractor, you may want to go with microwave, and if you have a drop lens, you're going to have to go to microwave technology. The other concern with passive infrared is the fact that since it's detecting heat, if you have high ambient temperatures inside the space, you're going to have to turn the sensitivity up. And if you're in a location like Las Vegas or Phoenix, Arizona, where you have an unconditioned space, you may not be able to turn the sensitivity high enough to be able to cut through the ambient heat to be able to see the human being go from one location to another. So that's what we would call a false negative. Somebody's going through the space, the high ambient temperature is preventing the sensor from being able to see the human being enter the space. Microwave sensor works a little bit differently. It uses a continuous beam. It has the same sensitivity range regardless of distance. When you change the sensitivity, you're changing the shape of the beam. So when you turn the sensitivity up, I describe it as a pumpkin, and when you turn the sensitivity down, it becomes a cucumber. What's great about microwave, it's great for abnormally shaped rooms with obstacles or obstructions. And it's also great if your fixture has obstacles like a refractor or a dropped lens. The concern with microwave is because the sensor can detect through plastic and glass, it will also detect through plaster and drywall. So normal building materials will cause somebody outside the area to turn the lights on, which is what's called a false positive. Lights turn on when nobody's inside of the space. Now, in a skinny tall space like a hallway, you can take the sensitivity and go from a pumpkin to a cucumber. But the issue with having a cucumber underneath the fixture, this torpedo shape, is as you walk down the space, you may have to be like right directly underneath the fixture to actually trigger the lights on. So typically in a hallway application, you're not going to want to use microwave. You're going to want to use passive infrared. If you're using a drop lens, you're going to have to use microwave, and you cannot use passive infrared. Another issue with microwave sensors is they can be oversensitive, meaning even turning the sensitivity all the way down, it may detect vibrating and moving objects inside the space, moving water, cables, pieces of paper on a desk may cause a false positive. Nobody's inside the space, but the movement is being detected. So in those situations, passive infrared should be used. The last concern about microwave technology is the fact that you don't want these sensors to overlap. So the coverages need to be fairly separated from each other, because if you have too much overlap, they're sending out a radio frequency signal out into the space, and where that overlap happens, you could have unintended triggering happening there, meaning the lights turn on when nobody's inside the space. So keep in mind, you need to make sure that your sensor is placed in the correct space for the accurate detection and performance. Sensor sensitivity and coverage is limited. Ensure proper spacing based on room height, shape, and size before installation. You may not be able to correct a mistake or an oversight after installation. Microwave sensors work on the Doppler effect and may be triggered by movement of objects in the space like paper, metal, cables, or water. Overlapping of PIR sensors is encouraged. Overlapping of MVS coverage should be avoided. If you have questions, we do have individuals that can take your call at 1-844-LightCloud. You can email us at support@lightcloud.com, chat with us on rablighting.com. Specifically, if there are questions that you have about how these sensors work, and basically any other Lightcloud Blue device, those first two documents that you see there, Lightcloud Blue User Guide and Planning and Startup Guide, 80 to 90% of all questions that you have could be answered specifically by picking up these two. We have discussions about occupancy sensors, placements, that switching using, God, lost it. Having the power turn off is all called out inside of those documents. So thank you for attending today, and hopefully you've learned a few things about Lightcloud Blue sensors and how they work with RAB high bay fixtures. Thanks. Bye.